Good morning, everybody. Hope you're doing great. Sorry I'm not with you. I'm sure for some of you, though, you're excited that I'm not there and I'm in your earbuds. So, anyway, normal day today. So go ahead. I know you see the warm-up there. So let's do all the slides that go with the warm-up. So pause it. I think there's 5 or 6 of them that go with them. Yeah, it looks like there's 6 of them. So let's go ahead and do all of those. And then we'll come back, I'll give you the answers, and we will jump right into 2-6, all about ratios and proportions. Okay, so pause this, hop onto that, and come back when you're done with the warm-up. Okay, so hopefully you're all done here. We've got to express the statement using an equation using an absolute value. Do not solve. There you go. So it literally does not care for you to solve it. Here is what your equation shall look like. There you go, equals 3. All right, let's hop on to our next one. All right, it says solve and graph the solution set. So when we solve it, again, we can list our 2 answers. If you'd like, in curly brackets, our 2 answers would be -8 and 2. And then if we were to see those on a number line, of course, maybe here's -8, bam, here's 0, here's 2. All right, it can be that simple. Okay, next one. Same thing, solve and graph. So -2 and 6 are your answers. Not great curly brackets there. What does that look like on your number line? Here's -2, maybe here's 0, and here is 6. There, now my number line is looking amazing. Okay, moving on. Again, more solve and graph. I think you get the graphing picture. -4 and 3 are your 2 values that k is equal to. All right, so for this one, the least and greatest temperatures covered by the guarantee. Again, didn't say anything about writing an equation. So, maybe you wrote one and were awesome. Maybe you didn't write one. So that should be that's terrible. Let's try that again. Fahrenheit, there we go. The other temperature, 42.4 degrees Fahrenheit. Okay. There are your 2 temperatures. And last but not least, pretty straightforward on this one. We have determined that x is equal to 5 as well as -21. Alrighty, so that brings us to today's lesson on 2-6, so ratios and proportions. Ratios, not new. This is something that you guys did a long time ago, I don't know, 5th, 6th grade. We touched on them a little bit last year in 7th grade. The book does some, hey, are these equivalent ratios? We are not going to do that because we should all know what equivalent ratios are. We are going to work on proportion, or what I like to call proportional equations. These are the kind of weird-looking equations, super easy to solve. We solve them by knowing the fact that the product of the extremes is equal to the product of the means. And these just have to do with the 2 different parts that make up a ratio. Okay? Rate, unit rate, those are 7th grade words we did last year. I hope you remember them. Scale model, we'll see those in some of our problems. But today, all about making proportional equations and solving them. They look fancy. They're super fun to solve. Okay, so here's what one of them looks like. How do we solve these equations? There you go. There is your secret recipe. Cross multiply. All right, so we're going to cross multiply, meaning I'm going to cross multiply these 2 numbers right? And then I'm going to cross multiply the other two numbers, terms, whatever you want to call them, all right? So on 1/2, we're going to get 12 times 3. That's going to be equal to n times 8. Now, great news, doesn't matter which pair goes first. So, like in other words, which pair is on the left hand or the right hand side of the equation. At the end of the day, it's all going to be equal to each other, right? So that's going to be just fine. And let's see what we get here. So you see I've cross multiplied here. We're going to divide, of course, by 8, right? And we're going to get, I think that's 4.5. If I did the mental math in my head right there, I think we're good. Okay. All right, moving on to our next one here. This one looks a little, different because instead of just having a variable by itself in like the numerator, and the variable could be in the denominator too, that's fine. I've got this expression x plus 4. So again, we're still going to cross multiply and divide. So look, 12 times 3, that looks pretty much the same. But remember, I want to multiply 4 times this. So now it looks like that. All right, 36, a little bit of distributive property. There we go. We'll subtract 16 from both sides, and that should give me 20. And then we divide by 4, and I get 5. All right, moving on. Again, straightforward. If you feel the need that you need to or want to solve these on your own, you go right ahead. All right, so this is going to turn into 10r equals 63. Right, divide by 10, divide by 10, r equals 6.3. Show your work, circle your answer. Some of you are better than that than others, okay? So we all got to get good. I mean, at the bare minimum, when you solve that, guys, it should at least look like that. Okay, here's another one with x minus 6, right, in the numerator. Again, we're still, right, you'll see me do that little weird x all the time. This just means, hey, cross multiply and divide. Let's see, that's 80. I think that sounds good. Distributive property kicks in, and I get 8x minus 48 equals 80. There we go. We're going to go ahead and add 48, right? We'll add 48 to both sides. 128. Divide by 8. And let's see, that's 148/16. There we go. Sweet. See, aren't these fun? Love them. Okay. The gear on a bicycle is 8 to 5. This means that for every 8 turns of the pedals, the wheel turns 5 times. Awesome. Suppose the bicycle wheel turns about 2,435 times during a trip. Whew. How many times would you have to crank the pedals during that trip? All right, so this is where proportional equations become super helpful to me. So let's look at this ratio right here, 8 to 5. And we now have to set up, right, one of these proportional equations, right? And it's, basically some fraction equals another fraction. So what do the numbers 8 and 5 mean, right? So I'm just going to, look, I'm going to write them right here, 8 and 5. So 8 is turn of pedal. Okay, 5 is wheel turn. All right. We're going to answer the question of how many times would you have to crank the pedals, right? So in other words, how many times would you have to turn the pedals? I don't know. That's what we're going to find out, right? This 2,435, right, is how many times the bike wheel turns. So this number is a wheel turn, so it has to go in the denominator. The hardest part of these word problems, and this is really what we're going to get when we think of proportional equations, is setting it up, right? And as long as, hey, in this case, our numerator had all the pedal turn numbers or variables, 8 and x. The wheel turn numbers 5 and 2,435 were together. As long as we set this up right, we're not going to mess this up when we go to solve it, right? So we're going to still solve with our cross-multiplying, little scheme that we're doing here. So 5x is going to equal this crazy number here. Good thing you can't see the calculator that I'm using, 19,480. I'm just kidding. I did that with mental math. Divide by 5, right? Divide by 5, and we get 3,896. So in other words, we would have to crank the pedals 3,896 times for our wheels to turn 2,435. That was awesome. Let's do another one of those. All right, Trent goes on a 30-mile bike ride every Saturday. He rides this distance in 4 hours. At this rate, how far can he ride in 6 hours? All right, so this one, a little bit different. No ratio here. Identify the two variables, right? That's what our fraction is going to be. And the great part about it is it doesn't matter which variable goes in the numerator or which goes in the denominator. We're good to go. So our two variables, hours and miles. It makes no difference. I'll go hours over miles. We could also set this up as miles over hours, and we're still going to get the same answer at the end. All right, so what do we know? Trent goes on a 30-mile bike ride every Saturday, and he rides that in 4 hours. So these two have to go together in one of my fractions, all right? So 4 hours is 30 miles. That's equal to 6 hours, and how far does he go in 6 hours? There you go. These are the most useful equations ever because we can use them in all kinds of stuff in our real day lives. All right. So cross multiply divide. I think I get 4x equals 180. Go ahead, divide by 4 and 45. What that turns into. Okay. A couple more, and then you're on your own. All right, in a road atlas. That's a map for you people that don't know what that word means there, okay? The scale for the map of Connecticut, capital is Hartford, of course. I know you guys knew that. There's its abbreviation. 5 inches equals 41 miles. Again, my brain's thinking there are two variables, inches and miles. Here's a pair, right? We can think of this as a ratio now, 5 inches to 41 miles. What's the distance in miles represented by 2.5 inches on the map? Okay, sweet. So these are kind of like some 7th grade problems we had last year, but now we just solve them with this cool, hey, I'm going to make inches and miles, right? So all right, 5 inches is 41 miles, and that's equal to 2.5 inches. Ooh, you see what I did there? Is how many miles? So, last year we'd figure out, okay, what does 1 inch on the map mean in terms of miles, and we'd take that number and we multiply it by 2.5. And in essence, we're kind of doing the same thing here when we cross multiply and divide. We're just a little bit fancier, with it. All right, so we'll cross multiply here, 5 and x, and again, you don't have to use x, you can use whatever you want. 41 times 2.5. Oh boy, 205. If that's wrong, let me know tomorrow. No, that's not right. That's that. There, I was doing okay. Okay, now let's see. Divide by 5. So divide by 5. We're going to take this, divide by 5, and x is going to equal 20.5, right? So in other words, 2.5 inches on our map will represent 20.5 miles. Okay? And last but not least, here we go. It's another scale map problem. All right. 1 3/8 of an inch equals 750 miles. The distance between LA and Washington, D.C. is that many inches, 3 7/8. What's the distance between the two? So again, setting it up is really the only tough part about this. So, we're still going to do inches to miles. If you guys want to do miles over, it makes no difference. We still get the same answer because remember, we're just cross-multiplying the means and the extremes, and they're always going to be equal to each other, and that makes everybody happy. So we could have 1 3/8, right, and 750. Those two go together. I get those from right there, right? Those are equal to 3 7/8. Now look, people. If we flip 3 7/8 and we put it down here in the denominator, we will not get this problem right because now we're not going to cross multiply the right two numbers together. All right. All right. So cross multiply here again. Not great numbers. I'm going to have 1 3/8 x, and that's going to be equal to, I'm running out of room, 2906. I'll go decimals here. Okay, so we get that 2,906.25. All right, then we're going to divide that by 1 3/8. Right, so not a good number here. I get 6, 3, 6, a whole bunch of other stuff. So, what is the distance between the two locations? Well, it's this. It doesn't say anything about, rounding or anything like that. I'd say it would be appropriate to round to the nearest whole mile. So let's go with 2,114 miles. All right. Again, we're rounding to the closest whole number. So that 6 does my rounding. Okay. All right, so you guys are good to go. You guys are going to be into your book practice. I know it's up on the board, but in case you're lazy, book practice today is page 119, and we're going to check out 15 to 42. All right, so you can get going on those. Then don't forget about your self-check for this lesson, and if you get both those done, show them to the teacher, and they'll give you the homework if everything looks good. So have a great rest of the day, and I will see all of you tomorrow. Sayonara.